I want everybody to graph f of x plus 6 and g of x equals x minus 6. Okay, so graph those two on Desmos. I'm watching you, so I can see if you're doing what you're supposed to. Here. You've got Desmos up, but there's no lines yet. Okay? And so, when we get those graphed, what are you guys noticing? What are some things that... Okay, that is probably not significant to what we're trying to talk about. Okay, what do you think, Lily? They're parallel. Okay, they do go out to infinity. All lines will do that. Some will leave that off. They have a positive slope. What's different about them? Okay, there's a negative and a positive of what? The 6, which is what? Where does that show up on the graph? It's your y-intercept. So 1 y-intercept is positive 6. The other is negative 6. Okay. All right. Anything else? Nothing too remarkable really about these. Let's see. I'm gonna pull up Desmos over here. Graph it over here as well, okay. I'm going to add one more thing in here. I want you guys to add this line, y equals x, right here. That's my green line that I have showing up on this graph. Okay. What do you notice about that green line? What do you think, Lily? It's halfway between, right? So there. So today we're talking about inverses. And so I started off with these two equations, x plus 6 and x minus 6. Because an inverse is something that undoes something that was done, right? So if I have x plus 6, that means I'm taking whatever number I'm plugging in, I'm adding 6 to it. What is the inverse or the opposite of adding 6? Subtracting 6, right? So these two undo each other, right? So I chose that one. Now, several of the things that we have written down are significant for these graphs, but they don't really matter for a lot of inverses, right? So what I want to do is test a few other inverses that we know, okay, and see what happens. I'm going to leave that line y equals x there. It may be important, it may not. We'll see as we go. What about if I had the graph y equals 4 times x? What if I have y equals 4x? What would the inverse of 4 times x be? What would be the opposite of multiplying by 4? Dividing by 4. So it's going to be x divided by 4. Okay, so are my red and blue lines, are they parallel? They're not. So what I'm trying to do is think of things that like matter for inverses, right? So it looks like that our first ones were parallel, but it doesn't really It's not always the case for all inverses, right? Do both of those lines have positive slopes? Okay, if they have positive slopes, they're going up from the left to right. So they do, so that might be significant. What about our y-intercepts? They all cross at 0, right? So I don't think that matters for inverses. Is y equals x halfway between? The y equals x is that green line. It's like kind of, right? Not in the same way as we were talking about before. But it does sort of go through the middle of this, right? So that might be significant. Okay, let's try. What about if I do, the square root of x? Okay, so if I do the square root of x, what is the inverse of taking the square root of something? Unsquare. How do you unsquare something? Or unsquare root something, I guess. Okay? The opposite of a square root is raising it to the second power, squaring it. Okay? Because a square root means what number times itself equals this value. So if I do that number times itself, it's going to undo what I have there. This one's a little bit odd here. What I'd really have to do, we're not going to. This red graph right here is my square root graph. It only applies for x is greater than 0. So that means y would have to be greater than or equal to 0 here. I'm just going to do this so it shows up. You don't have to worry too much about that. We'll talk about it later when we do domains of things. Let me do x greater than. Okay. So if I look at those two graphs, they both have positive slopes, sorta. They're increasing at least, right? Is x halfway between them? Sort of like the last one, right? It kind of goes through it evenly. Just to rule out positive slope, let me give you this one. What if I did like -2 times x? What's the opposite of multiplying by -2? Dividing by -2. Do those have positive slopes? They are going up from left to right, the blue and the red graph? No. So positive slope doesn't really have anything to do with it either over here. It has to do with that y equals x line, okay? And so what happens if two functions are inverses? The graph of a function can be reflected over the line y equals x to produce a graph of that function's inverse, okay? So this green line right here is going to be key. We're going to use Desmos quite a bit to test to see if things are inverses, okay? We'll also do it algebraically, but we can kind of rely on Desmos in a lot of cases. So, let's move on. All right, so the ordered pairs of the relation 1, 3, 6, 3, 6, 0, 1, 0 are shown below. Graph the inverse of that relation. Okay? Did I skip one? Is there a... Why did I start on example 3? Is this the next thing you guys have? Okay. Why did I start on example 3? Losing my mind, I guess. Need to go back and fix that. Okay. So, for some reason, 1 and 2. Do you see 1 and 2 anywhere else? Did I just put them out of order or something? Okay. I just... Losing my mind. Okay. Good to know. I mean, this was last year. I didn't redo these notes from last year, so it was last year that I was starting to lose my mind. It might be going all the way now. Who knows? All right. So, whenever we have a inverse of a function or a relation, it is going to switch our x and our y's. So, if this is what I'm starting with right here, then the inverse, for the inverse, we are going to switch the x's and the y's. Okay, I'm going to draw in, let me use a black line for that. I'm going to draw in that line dotted that we just talked about, y equals x. It has a y-intercept at 0, 0, and it just has a slope of 1. So it's this line that cuts that first and third quadrant in half, like that. So if I eyeball this, like if I do this just by looking, this purple dot right here, if it gets flipped over that line, it's going to end up right here, right? Now, the coordinates of our original point were 1, 0. What are the coordinates of our new point? They are 0, 1. Okay? If I look at that red dot right there, it would flip to end up right here, right? Our original would have been 1, 3. What are the coordinates of our new dot? 3, 1. Okay? If I look at that blue, I'm going to go to the blue one next. So that blue dot, if I flip it over, it should end up about right here. Okay? Coordinates of this point right here were 6, 3. What are the coordinates of that blue dot there? 3, 6. So sometimes whenever I'm doing these, like if the dot is really far away from my slanted line, I have a hard time like picturing where it goes. But this green dot, I could, if I wanted, just switch my coordinates. So if I use green for that one, the coordinates here are 6, 0. So what would the coordinates of the new point be? 0, 6 would be over here. Okay? So you can see that the x and the y coordinates just switch for the inverse of a function or a relation. Now I realize we just kind of have a jumbled mess. We're going to look at actual functions with equations here in a second. Okay? All right. So if I have this problem here, I've got a table, and I am supposed to fill in the table for the inverse and graph it. Okay? So if I have 1, 2, 3, 4, 5 over here, 2, 4, 9, 4, 12, what is it going to look like whenever I do the inverse? I'm going to flip those columns, right? So that will look like this. Now I've got 2, 4, 9, 4, 12 here, and I've got 1, 2, 3, 4, 5 over here. So let's use a different color to graph those points. If I graph the point 2, 1, that's here. 4, 2 is here. 9, 3 is here. The point, now watch this, the point 4, 4 is right here. Did it move? It did not, because it was already on that line, right? When you switch it, it didn't change anything. And then the point 12, 5 is right here. Now, if I draw in that line, that y equals x line, look at it here. Okay, does it look like we have reflected those points? Okay, the only one that doesn't look like it did anything is that point that is 4, 4. If you got a point on the line, it doesn't actually flip because it is on the line, right? But everything else just flipped right over that line. I think it is hard to do this by looking at it. I can flip something over the x-axis pretty easily by looking at it. Sometimes I think it's hard to do this by looking at it. That's why it's so important to remember that whenever you switch your x and if you just switch your x and y's, that way you can graph it without having to just guess at it. Okay, now this question right here says, is the inverse a function? Okay, so the red dots, are my red dots, is that a function? What are we looking for function? Vertical line test, right? Do I pass the vertical line test? No, right there. I've got two that are on top of each other. So this inverse is not a function. Let's go back to the pen. No, not a function. Okay? All right, let's keep going. All right, so graphically is one of the main ways we're going to verify if something is an inverse. Okay? So if I get something like this and it says, are these two inverses? Okay? And I have this. What I want to do is I want to graph the line y equals x. So I'm going to graph y equals x. The line y equals x. Make this a little bit smaller. Okay. It has a y-intercept at 0, 0. It just goes up 1 over 1. I'm just going to put me some dots right here for this line. Make a nice little dotted line there. I'm going to do the same going in this direction. There. So does it look like I took that purple line and flipped it over that red dotted line? I think so. Or another way you can think of it is if you guys actually have a piece of paper, could you fold it on that dotted line and the pieces would match up? And I think so. I think the answer for that would be yes. So in this case, these would be inverses. Yes, they are inverses. Okay? All right. Let's keep going here. Let's try these. I gotta erase that because my dots are. Let's draw that same line, y equals x. Let's draw that here. Starts at 0, 0. It just goes up 1 over 1. Does that look like you could fold it in half on that line and those sides would match up? I don't think so. You can, if you're really not sure, like if you're not that good at looking at this graphically, you could like check some points. Like for example, this point right here is -1, 1, which means the point 1, -1 should be on the other graph. Right there it is. It is on the graph, but is it on the other graph? Is it on the black graph? It is not, right? Or if I picked, like, this point right here is the point 2, 4. That means the point 4, 2, 4, 2 right here should be on the other graph. Is it on anything? No, it's not. So if you're not sure, you can pick some points and try to check, So this one would be a no, right? Okay, let's keep going. All right, now this one gives us a graph, and it wants us to sketch the inverse. I'm going to draw in that dotted line one more time. Okay? Oh, gosh. Visually, I have a really hard time doing this. I cannot really picture what this is going to look like. Some of you guys, I usually find kids that are really artistic, that are like really good at drawing things, are better at doing that just by looking at it. I do not have that skill. So what I have to do a lot of times for this is I take it point by point, right? So like, let me use red on the red graph. So for example, this point right here is at 0, -4. What's that point going to be on the inverse graph? -4, 0. It's going to be that blue point I just drew right there, right? Okay. Then if I look at, say, this point right here, that is 1, -3. So what's that going to be on the new graph? -3, 1, which is right here. Okay. Here is another point on our graph. That is 2, 0. What's that on the other one? 0, 2. 0, 2 would be right here. They okay over there?
Can we go check?
Oh, it's not. They sound like they're having more fun than us, though, don't they?
Drew and Holt.
That's the problem. Drew and Holter, and that, yeah. Drew is always amped up, but he was definitely amped up on the higher end of normal for him, which is nowhere close to the normal range for a normal person. So, he was excited about the fire drill, I think. All right, so we got 3, 5. What's that going to be? 5, 3. So 5, 3. Okay, let's try some points from over on this side. I've got the point right here. That one is -1, -3. So that's going to be -3, -1 right here. I'm starting to see sort of what's happening. It's sort of like this has been turned on its side. If I take this point right here, I'm just going to draw that one. That one's easy to see where it flips to. If I take this point right here, this point right here is -3, 5. That's going to go to 5, -3. All right, so if I take and connect all these blue points now, I'm going to get this graph. Okay, so some of you guys may have been able to see that in the beginning, just like it kind of looked like that's what it was going to end up at. I have a hard time doing that. I can't really see what is happening there. So, I would suggest if you are like me and it looks like a jumbled mess when you try to start flipping, then actually just look at those points, because I think it's pretty easy just to switch the points, right? Like if you just switch the points, you just got to be careful with where you graph them at. All right, so is the graph of the inverse a function?
No.
No, it is not. Okay. Was the red graph a function? Sure about that? The red graph, the original parabola we got here, does it pass the vertical line test? Yes, it does. So the red was a function, but the inverse was not a function, right? So that is something we're going to talk about more here in a second. All right, questions here? All right. Okay. Okay. The inverse is a... I need to go back through my notes, don't I? I was really losing it whenever I made these. Okay. The inverse is a function. Like it really, really is a function. That's just a typo there. The inverse is a function if and only if the function is a 1, 2, 1 function. Okay? So we talked about one-to-one functions back whenever we were talking about functions in that very first part, right? And one-to-one functions have to pass your vertical line test and your horizontal line test. So, 8, 9, and 10 ask us, are the inverses of these functions also functions? So they're not giving us the inverse, and so far I haven't taught you how to find the inverse, right? I'm going to, but I haven't showed you yet. But I want to know, even before I begin, if the inverse is going to be a function, okay? So we're going to use Desmos for this. So if I pull up Desmos over here, I'm going to get rid of all this right here. And I'm just going to graph the equation. F of x equals 2/3 x minus 1. It's just the equation of a line, right? Y equals mx plus b. Is this graph, Angel, is this graph a one-to-one function? Okay? It passes our vertical line test, right? Vertical line test, and it passes the horizontal line test that I'm not tall enough to do for the problem there. So, if your function is a one-to-one function, the inverse is also a function. Okay? Let's try the next one. We got x plus 2 over x minus 1. Move this over to this side. So, it's easier to type in if you hit the division key first to make the fraction, and then do x plus 2 over x minus 1. Okay, what about that one? All right, I'm going to do this. If I do y equals a, why is it not doing that? Or y equals 1. Okay, if I do like y equals 1, it's going to put this slider beneath it, and then I can kind of do the horizontal line test. Do I touch more than once at any point? If so, it's going to happen like right here at 1. But am I touching that line? It looks like, yeah, that's going to be a horizontal asymptote, right? It looks like it's touching it whenever you're zoomed out, but if you zoom in, it's not actually touching. So I think that's a horizontal asymptote. It does not touch. So if I go back to the main view, I think this passes the horizontal line test. I think this is a one-to-one function. So its inverse is also a one-to-one function. Okay. Can anybody answer number 10 before you graph it?
No.
Okay. Is that going to be a function?
Maybe.
Or is your inverse going to be a function?
I don't think so.
What kind of graph is it going to be? It's a 9 minus x squared. Oh, I'm seeing it from Lily back here. She's doing this. Yep, and Trinity's doing that too. It's going to be a parabola. Is a parabola going to pass the horizontal line test? It will not, but let's graph it just to be sure, to make sure I've not truly lost it today and forgotten everything. There's a chance that I have. Yeah, that definitely does not pass the horizontal line test. So it's not a one-to-one function, so your inverse would not be a function on that. Okay? All right, questions? All right, we got to learn how to find these. We got to learn how to find the inverse by hand. Okay? All right, now, this requires a little bit of algebra. If solving equations in algebra is not your strong suit, it might be a little tricky, but we can use Desmos at least to check our answers in the end, okay? So, this is how you find an inverse, okay? The first thing that you are going to do is in the equation, you're going to switch your x and your y, okay? So, that will look like this. We'll have x equals 2y plus 4. Okay, everybody got that? Just like our points to do the inverses, we switch x and y, right? So if we've got an equation, we're going to switch the x and y. So the next step is to solve for the new y. We got to get that y by itself. Now, this is going to be a little tricky because it's not like you're solving to get a number. Like the answer is not going to be 10. You're going to get a new equation is what's going to happen. Okay? But you do it just like you would solve an equation. In a way, it's even easier because you don't have to like actually divide or multiply or anything like that. So, so if I'm trying to get that y by itself, I need to get rid of the 2. I need to get rid of the 4. Josiah, what would I get rid of first? That 2 or that 4? 4. How do I get rid of it? Good. I'm going to subtract 4, and I'm going to subtract 4. This goes away over here. Okay? What is x minus 4? Can I put those together? This guy right here has an x. This one does not. There is a 1 in front of it, but that 1's being multiplied by an x. So they are not like terms. We can't put something with an x together with something that's not, doesn't have an x. So what we have to do is we just have to write it like this, x minus 4. Like I said, in a way, it's even easier because you don't actually do like the math. You just write it down. Write down what's happened, right? Okay? Now, I'm trying to get that y by itself. What do I need to do to get rid of that 2? Divide. So I'm going to divide by 2. It will cancel here. It will cancel here. Can I do x minus 4 divided by 2? Not really, right? Like, I can't really do anything with that. So I'm just going to write it. X minus 4 all divided by 2 equals y. Okay? And then the last thing that we usually do is we will replace the y with this notation right here. It's an f with a little -1 exponent of f of x. That does not mean you're actually raising anything to the -1 exponent. It's just our notation that means the inverse of x, right? So this means the inverse of x. So we will normally write our answer like this: f inverse of x equals x minus 4 over 2. We typically put the f inverse on that left side, so I just wrote it. Yes, it's a -1. Now, let's use Desmos to check our answers. Let me show you how you're going to check your answers, okay? It has to do with what we did at the beginning, okay? So I got y equals 2x plus 4, and I've got, don't use the f inverse typing into Desmos because it's not going to like that. It can't read that notation. Just call it y again. Y equals x minus 4 over 2. All right, I'm going to graph those, and then I'm going to graph the line y equals x that we kept graphing earlier, right? In fact, if you hit the gear right here, you can make that a dotted line so you remember which one is our y equals x line. Does it look like the blue graph is flipped over the green graph? Yeah, that looks good. So this is what you're looking for. You're looking for your answer to look like it was the original graph flipped over that dotted line. If it looks like that, then that's a good sign you probably did it right for that. Okay, questions? Okay, so let's continue on. All right, we got 2 more that we're going to find the inverse of. Okay, let's do number 12. We've got, for number 12, this one they used f of x notation. But f of x pretty much is your y, right? You can think of it as your y. So we need to switch x and y. So we're going to put x right here. X equals -4 minus 5y over 2. Oh boy, this one's worse, right? But the same thing's still true. You're trying to get that y right there by itself. All right, so ideas. What do you think we should do first? We got a -4, a -5, and a 2 we got to get rid of. What do you guys think? That 2. So everything's divided by 2. How do we get rid of that divided by 2? Times it by 2. So we're multiplying by 2 over here, which just cancels it out. And we multiply by 2 over here. What is 2 times x? It's just 2x. We can't do anything else with that, right? 2x. And then the stuff that we got left over here is negative 4 minus 5y. And for those of you that like to skip steps, I cannot stress to you how much you do not need to skip steps on these, because you're going to mess it up pretty bad if you do. Okay, you need to copy everything down, every line. Okay? All right, Jasper, next we got negative 4 minus 5y. We got to get rid of that negative 4 and the negative 5. Which one of those do you think we need to get rid of first? Okay, whenever we're solving equations, we want to start with the numbers furthest away from our variable. Okay, so this one, the 2 was furthest away because it was like downstairs. It wasn't even on the same level, right? And then now we want furthest away. 5's right next to that y, so we're going to wait till last to deal with it. We got to get rid of that negative 4. How would we get rid of that negative 4, Jasper? Okay, what's the opposite of a negative 4? Positive 4. So we are going to add 4 and add 4 right here. Okay, so I've got 2x plus 4 equals negative 5y. All right, we're almost there. Again, 2x plus 4. I didn't add those together because the 4 doesn't have an x. Can't put those together. So, Victor, I got a negative 5y. How am I going to get rid of that negative 5? We're going to divide. Very good. It feels a little like you should add the 5, but it's right next to the y, so we need to divide, right? So we're going to divide by negative 5 and divide by negative 5 over here. And that'll get rid of this. So we would write our final answer as f inverse of x equals 2x plus 4 over negative 5. Okay? Let's check this on Desmos. We got, I'm going to leave that y equals x there because that's what we're using to check. We got f of x equals negative 4. Oh, wait. Oh, gracious. What have I done? Negative 4 minus 5x over 2. And then my answer was y equals 2x plus 4 over negative 5. Okay, does that look right? It looks reflected to me. You could check some points to be sure. I think we've done that one correctly. Okay? All right, let's do one more by hand here. We've got f of x equals x plus 1 cubed minus 2. That f of x right there is really like our y. So when we switch our x and y, we're going to have x equals y plus 1 cubed minus 2. Oh boy, now we got a cube to deal with. We can do it though. Okay. All right, Trinity, what do you think we should do first? Good. And how are we going to do that? Add that 2. That'll go away here. We'll add the 2 on the other side. We just have to write x plus 2. We can't put those together. And we got y plus 1 cubed. So we're trying to get that y by itself still. What do I need to get rid of next? The cube. How do I get rid of a cube? It's not a square. It's not a square root, but it's close. To get rid of a square, we would use a square root. To get rid of a cube, we have to use a cube root. So it looks like a square root, but it's got this little 3 out here. And so we would cube root both sides. Oh boy. All you need to know, though, is that cancels out the cube. So now we're just going to have to write it this way. Cube root of x plus 2 equals y plus 1. Okay, we're almost there. Okay? Angel, what's the last thing I've got to get rid of? The 1. How do I do it? Subtract 1. Okay, it may feel like you can subtract that 1 from that 2. But the 2 is underneath the cube root. You cannot subtract the 1 from that 2 because it's not under the cube root. So you just have to write it out. Most of the time, you don't put anything together when you do these problems. You just like keep making the equation longer, right? So it's going to be cube root of x plus 2 minus 1 equals y. And that minus 1's not underneath that cube root. And so if you want to write it with inverse notation, you would have the cube root of x plus 2 minus 1, like that. Okay, we need to check this one with Desmos. Let me pull this up over here. I'm going to leave y equals x up there. And our original was f of x equals x plus 1 cubed minus 2. And my answer, do y equals, don't try to do f inverse. It doesn't like it. Cube root, you're going to go down here. And that's just the square root. Go to functions. I think it's going to be over here. There it is. It's got the square root. It's at the very bottom. It's got the square root with a little n on the outside. It'll put the root for you, and you'll have to type a 3. That'll be a cube root of x plus 2 minus 1. Okay, does that look like it splits over y equals x? I think so. It's a complicated looking graph. More complicated than the ones we had looked at before. They were just lines. But it does look like you could fold that graph in half and it would match up. So I think we have done it correctly. Okay, questions? All right, let's see here. Okay, so some of the questions you are going to get are going to be multiple choice. Okay? You can solve these by hand. You can use Desmos to graph. Okay? Now, in my opinion, it is faster to solve these by hand. Okay? Yes. I don't think so. Why did you choose D? Because that plus 4? Oh. You're just guessing? Okay.
Actually,
you got a minus 4, so I feel like maybe there's going to have to be a plus 4. We'll just have to see, okay? All right, now, if I solve this by hand, I've got x equals 1/2 y minus 4. What's the first thing I would have to do? Add the 4. So I got x plus 4 equals 1/2 y. What's the opposite of multiplying by half? Dividing by half, that is true. So, dividing by half is complicated. I don't like dividing by fractions, right? So, if I'm multiplying something by 1/2, I'm taking half of it, right? What's the opposite of taking half of something? Which would be, doubling it, right? So, and doubling would be multiplying by 2. So if I multiply, I could divide by 1/2. It will work, but do you see a divided by 1/2 over here in your answers? I don't. So if you have something like 1/2, you can multiply by 2 here. 2 times 1/2 is 1. Goes away, right? And then I'd have to multiply by 2 over here, but I have to put parentheses around this, okay? I have to multiply that whole side by 2, not just the x. So, what do I have to do with that 2? I've got to distribute, and I'll get 2x plus 8 equals y, so C would be my answer. Now, let's say that the stuff that I've been showing you is foreign, and you don't know how to solve that by hand. Desmos, you can use Desmos for this. Type in y, or f of x, y equals x, leave it, f of x